Okay, hello everyone. Welcome to the International Methods Colloquium. My name is Justin Nessery. I'm an associate professor of politics and international affairs here at Wake Forest University. The IMC is a periodic online interactive seminar discussion on the application of quantitative statistical methodology to the social sciences, sponsored by Wake Forest University and previously sponsored by Rice University and the National Science Foundation. The IMC is affiliated with the Society for Political Methodology, which hopes that you will support quantitative research in political science by joining. The membership fee is just $10 a year for graduate students. I will post a link to join the society in the Zoom webinar chat window after this introduction. This week's speaker is Amelia Hoover Green, an associate professor at Drexel University, giving a talk entitled Reconsidering Civil War Onset, Battle Death Mismeasurement, and Causal Inference. Amelia's talk will last between 30 and 40 minutes, after which point we'll take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window. You can ask questions at any time during the talk, but questions will be held until the end of the presentation unless they're definitely very short and clarifying. A link to Amelia's slideshow will be available in the Zoom webinar chat window so that you may refer to it throughout the presentation, and I'll post those links right after we get started. And now I'd like to welcome Amelia Hoover Green to the International Methods Colloquium. Amelia, welcome.
Thank you. It's nice to be here. This is a first outing for this project, but I suppose I'd like to start by thanking Justin and the other leaders of the IMC for the invite. And with that, I will just kind of hop in. So it's called Reconsidering Civil War Onset, and really this is an opportunity for me to think about the ways in which the terrible the terrible battle death measurement out there in the universe and other measurement out there in the universe affects inferences about things that we think probably shouldn't be so directly affected. So as a little bit of background, since not everybody is a Civil War specialist, I'm sort of working from 2000 to today. There was a Civil War onset literature boom, and I'm thinking here of folks like Doyle and Sambanis, Fearon and Leighton, Collier and Heffler, Howard Hager and Nick Sambanis. And that has been followed in the last several years by what I would call theoretical refinements. So the kind of let's add another independent variable sort of model of social scientific advancement. In addition, there have been a lot of debates about model specification, and in particular, more recently, some applications of machine learning in recent papers about sort of specification. But this debates about model specification aside, right, we haven't seen much in the way of kind of taking seriously or really measuring the effects of poor measurement. So there's a robust discussion about definitions of civil war and onset, and everywhere in that literature, I'm thinking particularly about the nice review that Nick Sambanis gives in his 2004 article. There's clear acknowledgement that battle deaths are hard to measure, that battle death measurement varies sort of complexly, but there's not much engagement with sort of specifics of measurement. Meanwhile, across the aisle or across the discipline, we have increasingly sophisticated measurement models. And here I'm thinking primarily of sort of latent variable estimates, also multiple systems estimation, which I can take questions about if you'd like. I'm not going to explain it because that would be another whole talk. The problem here is that these measurement models are usually really only tractable for subnational variation. There's no earthly possibility of getting an MSE estimate for multiple country years. Lastly, I just want to say, because some folks have sort of uh, recently I've been dinged about like being on my high horse about this stuff. I think it's notable that the modal paper on political violence, including Civil War and Civil War onset, in a top 5 journal in 2017-18 is a regression analysis with a country year unit of analysis using off-the-shelf data and having no measurement model. So that is to say most people, including people who are doing great work and getting published in really great outlets, are not treating, well, here's my slightly rude take, are not treating descriptive inference with the same sort of care that we tend to treat causal inference. So again, a piece of review. There are some problems with battle death measurement, I may have mentioned. Occasional overreporting and very frequent underreporting. So what we have found in the cases for which rigorous estimates are available is that sort of what I would call expert guesses in some of my work tend to be quite low. So for Kosovo, which was a short war with a solid pre-war reporting system, nevertheless, about 40% of all killings in Kosovo were counted. For El Salvador, which is a case that I've just finished a paper on, there were, depending on the sort of your placement in the confidence interval, we're talking about somewhere between a third and a quarter of cases ended up being reported. That's both military and civilian. This underreporting is probably related to the independent variables that interest us, but that underreporting, that association is neither consistent nor simple. So we can't just say, oh, the bias is probably conservative because I don't see a problem of urban bias. That does not strike me as a useful kind of comeback to questions about complex underreporting. There's also limited ability to distinguish battle-related deaths from others, and as I've mentioned, no rigorous estimates for most country years. And if you would like an amazing piece of work that illustrates this, I will direct you to the PRIO battle deaths dataset coding decisions document by Bethany Lacina and Gabriel Uriarte from 2009. I rely on this all the time. I use it in my methods classes. It's fabulous. And it's also really scary because we're talking about a limited number of sort of encyclopedic sources, mostly not estimates based on rigorous estimates, etc. Okay. So what am I doing here? This is kind of in the middle of a developing research trajectory for me. My sort of grad school MO was to loudly complain that the results are probably wrong and make sort of fundamentalist arguments about who should and shouldn't use raw or naive data. So you can imagine that went great for me. And I think, you know, that's cool with me. I've become less of a fundamentalist. What I'd like at this point in my life is a sort of rigorous and routinized way to direct people toward sort of, uh, what do I want to say, principled investigations of the possible effects of measurement error without having to have a solid estimate for every unit in your universe of observations. So more recently, I've been working on models built with causal models built with rigorously estimated dependent variables, sort of comparing those to raw or naive dependent variables to see what the effects are, just literally comparing the effects on causal models of subnational variation in homicide in Colombia. So that's a paper with Eula Kruger, who is at the University of Michigan and who helpfully presented that for us yesterday. This project is what I'm calling a hard case in the sense that battle deaths are not directly implicated in the dependent variable here. So if measurement matters, then if battle death matters to onset measurement, and onset measurement uh, matters to our estimated causal models of civil war, or associational models, I suppose is more appropriate to say, then this is kind of strong evidence that measurement matters more broadly, or at least that's how I'm going to frame it for you today. Um, this is also a case in which I don't directly model those complex relationships between battle deaths and key independent variables. Rather, we're just going to take kind of a plausible random distribution of real battle deaths informed by the measured battle deaths. finally, sometime in the future, when I get a fairy godmother and some grant money, I would like to help. I would like to build an R tool to sort of facilitate doing this on a more kind of routine basis. For now, however, some quick results from the subnational study I mentioned. I have on the screen my favorite quotation from literally every interaction I had in graduate school and as an early assistant professor. Um, and I'm finally able to say, yes, yes, it does. So I won't talk about every graph on this page because that would be crazy. But I want to draw your attention to a couple of things. So, what you're looking at here in each of these 15 graphs is um, the sort of colored, the teal and purple bars are the confidence intervals for raw data. The distributions there are posterior distributions of coefficient estimates pulled from 3 different multiple systems estimates. So there are 5 systems. The red estimates take all of those into account. The orange and yellow take just one, etc. So essentially, this is comparing the results of a kind of naive approach to something that pulls from a rigorous estimate. And so I just want to show you a couple of these. One is in the top right, proportion urban. So you can see here that essentially the the multiple systems estimates, the measurement, the version with the measurement model, A, they all seem to agree with each other. B, they seem to support, roughly speaking, system 2 over system 3 in terms of kind of the effect of the proportion urban. The other two that I want to mention are municipal wash investment and HDI, the Subnational Human Development Index. That's in the middle row. Yeah, middle row, middle graph, and right graph. And what we see here is that with wash investment in particular, neither of the naive estimates gives us much. So it seems insignificant. And what we find using MSC is a much more significant result. Um, on the other hand, for Human Development Index, we see 2 very significant agreeing results from the 2 naive estimates and a sort of eh from MSC. So the short answer here is that yes, the regression the regression results do change when you have a measurement model, and therefore we should probably try to have measurement models when we can. Um, this is not a context. Civil War onset is not a context, or really any kind of cross-national political violence study is not a context in which a lot of measurement models are actually available. So, what I've done here um, is to simulate. So, as a quick review, or possibly a brand new piece of information, depending on your position in the discipline, here's the operationalization of Civil War and Civil War onset that I'm going to be using in this study. And to be clear, I'm using this operationalization not because it's like definitely the best one, but because it's relatively easy to code from battle deaths. And really, operationalizations don't seem to make much difference to sort of baseline models of Civil War onset. In any case, Civil War happens between a state and an organized non-state group. Furon and Leighton want there to be at least 1,000 battle deaths. Doyle and Sambanis and Doyle himself in his 2000, or sorry, Sambanis in his 2004 article are kind of relaxing that to 500 to 1,000. Onset is the first year in which 100 were killed, or in which a violent event occurred that was followed by a sequence of actions that came to satisfy, etc. We code a new onset if power changes hands or if a new party joins the conflict. An end of war either is coded by observation of victory, demobilization, truce, um, or by 2 years of peace. And by 2 years of peace, I'm going to say in this simulation that means we basically code a new onset whenever whenever battle deaths drop below below 100 for 2 years, or I'm sorry, below 25. This is a decision I've made recently. So here's the basic procedure. Um, I, for the simulation, that is. Sorry, I'm looking at my time on my phone. Um, so I fit a sort of standard logistic regression model based on results from Hager and Sumbanis. The universe is all countries with a population of at least half a million, 1989 to 2011. And the reason it's 1989 is that that is when the UCDP starts measuring battle deaths at the conflict year level, which can kind of be translated into the country year level. So for each country year, I take the measured battle deaths um, and produce from that a log normal distribution of plausible true battle deaths. So log normal distributions are increasingly common as priors for multiple systems estimation. That is what I used when I was working on subnational variation in El Salvador. Um, and we'll talk about why that is in a moment. So measured battle deaths essentially are kind of giving me a prior distribution. From those priors, I simulate 1,000 new battle death vectors. So 1,000 possibly plausibly true vectors. And these also, the thing I didn't know when I was starting this project is how involved it would be to actually code war, onset, peace duration, legs of all of these, and neighbors at war from 1,000 brand new battle death vectors. So that is computationally expensive, and it's been like a real thorn in my side. Um, Finally, of course, we refit the model 1,000 times. I record the coefficient estimates, z-values, etc., for each of the sort of simulated battle death vectors. What does the distribution look like? It's a log normal. This is a picture of, oh, let's see, 417 overlapping subnational strata in El Salvador. And the x-axis here is the multiplier. So you can see that there's a lot of strata for which the multiplier is sort of 1, 2, 3, 1, 2, 3, 4, and then a few trailing off to the right side where the multipliers go kind of bonkers. And those tend also to have large confidence intervals, which are not shown here. But um, this turns out to be true across a variety of cases. So uh, the log normal describes variation in multipliers or in estimated multipliers across strata in Colombia, um, as well as in El Salvador, in Kosovo, as well as in El Salvador, et cetera. And so that to me provides some evidence of kind of the range of underreporting that we should be thinking about. And that again, that's not an obvious thing to say, right? Because it might be true that the range across country years is quite different than the range across, for example, department years in El Salvador or municipality years in Colombia. Um, yeah. So in this case, so this is a sort of log normal distribution of multipliers from El Salvador. Given that I'm sort of trying in general to make this a conservative exercise, oh, that's a terrible graph. Hello. Um, these are the log normal distributions of multipliers that I use in this simulation exercise. What's hard to see here is that there are essentially 5 groups of 200 simulations each. And in these 5 groups, the log normal distribution has a different log mean, which is to say the sort of average multiplier. And within each of the 5 groups, there's a spread of different log standard deviations. Um, yeah, but as you can see, right, we don't have, our graph here does not go to 20 on the x-axis. I actually artificially cut off the possible multipliers at 8. I also add the possibility of underreporting, or sorry, of overreporting. So a multiplier from 0 to 1 is possible in this simulation, even though it essentially never shows up in our other subnational work. So this is, I think, a conservative set of possible priors. Um, what does the model look like? The model looks like a very standard Civil War onset model. Um, so ruggedness, I added soil quality because it gave me some interesting results to think about. Um, so those are some geographic things. The population is always a standard control. There are a number of sort of governance related variables. Polyarchy, which is highly correlated with both Polity 2 and the liberal democracy score from VDEM. Anocracy, which is the standard -5 to 5 on polity, a dummy variable. Presidentialism, another dummy. PTS from the Political Terror Scale Project. Peace duration, new state, many usual suspects here. GDP growth. And then, kind of nodding to horizontal inequality approaches, I've also included measures from the politically relevant ethnic groups data. So the EPR data set, ethnic domination, ethnic exclusion, and finally, regional polyarchy. And that's the median of the measured polyarchy score in the country's region for that year. Geography does not vary by time, though perhaps soil quality should. And finally, I have three variables that are not included here. Two because of incomplete data, and one, as I mentioned earlier, neighbors at war is just really computationally expensive. Um, so for every simulation, that is an entire new set of onsets and onsets and wars, which means that there's an entirely new set of neighbors at war, etc. So that's a goal. That's a developmental goal for me, is to get that actually included in the work. Um, so this is the baseline model. I'm realizing literally as I speak that I have failed to include the baseline model sort of results as a table, but I will be showing them to you in the context of some graphs in a moment. Um, so I then want to look at that dependent variable. So these are hard to look at. I couldn't think of a better way. You know, we live and learn. So on the top of this slide is my coding of Civil War onset. And I don't show the countries in years, but the sort of horizontal axis is countries, and the y-axis is years from 1989 to 2011. And as you can see, for my coding based on the UCDP battle death data and the Fearon and latent operationalization, these are the onsets we have on the top. If we then simulate battle deaths, um, on the bottom, I have a slightly different measure, which is rather than 1 or 0, this is a measure of, in effect, uh, in what proportion of my 1,000 simulations did that country year experience an onset? And there are cases for which it's just really clear. So you can see some matching red blocks top to bottom. You can also see a number of cases for which either the year of onset or the existence of a war at all is a little iffy, a little squidgy. You can see cases where there's, no war for the baseline model, and sort of a confusing war that might have started in at a variety of times or places in the simulation model. So that's our dependent variable. Um, or rather, those are our dependent variables. This is a kind of detailed look. So in particular, some changes from top to bottom. You can see that everybody that we code Senegal as having an onset in 1993. If we use the baseline data, um, that's usually true with the simulated data, but we also get some onsets in 1990, some onsets in 1992, and so on. Um, so there's a lot of potential for variation. And the question is whether, the sort of acknowledging underreporting, incorporating that into our dependent variable, and then rerunning our models, whether that actually makes a difference. Um, Unsurprisingly, I'm going to argue that it does. So, what I'm showing you next is my not so sophisticated attempt to kind of visualize the breadth of results from these simulations. So, what you're looking at here on the left is for a Civil War threshold of 500 battle deaths. On the right, a threshold of 1,000 battle deaths. Both of these y-axes are just simulation number, and the reason I've laid it out this way is that the simulation number shows us something since the mean of the log normal distribution kind of goes in these five increasing groups. Um, the large pink dot at the bottom, simulation number 0, is the baseline result. And as you can see, so this is it. This is our distribution. The ruggedness variable doesn't. There's variation certainly, including in some cases real positive significance that is not shown in the baseline model, but those are not that common. So in general, while there's variation, there's not that much. Um, I wouldn't change my substantive judgment based on this, or at least I certainly wouldn't change it for a threshold of 500. I might for a threshold of 1,000. Um, yeah. So I now just kind of want to talk through a few of these that are, I think, interesting. Soil quality is kind of a new variable that I've been thinking about. As you can see, relatively, it's sort of marginally significant for a 1,000 battle death threshold in the baseline model, but as the mean of the log normal increases, you get more and more models where soil quality seems significant. Um, Similarly, polyarchy. Um, Polyarchy seems to get less significant for a 500 battle death onset. It goes from usually not significant to almost never significant. Um, Anocracy is an interesting one to me. So, taking a look at the right hand side graph, one thing that you can see here is that it's clearly positive, but definitely not significant in the sort of baseline model or in a model in which uh, the variation in battle deaths is quite close to the original measured count. But as the mean of the log normal gets larger, which is to say, as the sort of true number of battle deaths, true simulated number of battle deaths increases, it's not the case that this is a slam dunk, but it is the case that a significant number of iterations show a significant impact of anocracy at least the zero point 0.9 significance level, and in some cases at the 0.95 level. Which I realize I should have said this at the outset. The red line is 0. The blue lines are 1.66 standard deviations from the mean, or a 90% confidence interval, and the green lines are a 95%. Okay. Um, Sort of more changes in results. And the thing that interests me are the cases in which, like regional polyarchy, we see changes over the spread of the log normal means. So what do we think about the sort of true level of battle death underreporting? In some cases, that matters not at all. I'm barely even going to show you log population because it's so significant in every model, no matter what. No worries about log of population. But in cases like this, we can see regional polyarchy is kind of marginally significant in the base model. But as we start kind of simulating more unreported battle deaths, the proportion of iterations that show a significant effect really increase. Um, Presidentialism, likewise, we see a really what looks to me like a significant shift from in the first group, and particularly in the baseline, you see no significant effect of presidentialism, and by the time we get to the top group, around half of simulations show at least marginal significance. So I've sort of repeated this exercise for all of these kind of bog standard uh, variables. Political terror scale is particularly interesting to me. I wonder whether it's because of the truncation of the variable, but notably, at least for a threshold of 500, it's quite significant and positive. That is to say, political terror is associated with greater likelihood of civil war onset. But after acknowledging or after simulating a sort of uh, wider range of underreporting, we see that it's almost never significant. Um, Similarly, GDP. So it's still a mystery to me why this model using 1989 to 2011 as the period, um, sees GDP, and by the way, this is lagged log GDP, not GDP this year, for which the association is unsurprisingly enormous. Um, it's still a bit of a mystery to me why I don't reproduce some of the earlier results. Um, Maybe the Cold War was weird. Maybe the causes of civil war have actually changed. Maybe there's a problem with my model. It could be any of these things. And I'm still sort of puzzling through that. But notably, right, GDP, at least in the 500 battle death threshold case, goes from marginally significant to almost always highly significant, which I think is fascinating. Ethnic domination is almost never significant. The end. So there are several cases here where there's no real effect of simulating battle deaths, and I think that's important. Um, I still don't fully understand it. I can make some sort of informed speculation, but I don't really get it, I have to say. Here's ethnic exclusion. So, both of these measures, domination and exclusion, the variable is measured as the proportion of the population that belongs to a group that either is dominant or is excluded. Um, but as you can see, it's rare for these variables to show a significant effect. Peace duration, as previously stated, always significant, always, no matter what. Always with lots of different specifications of how we're going to kind of deal with the declining impact of peace duration over time. All right. Oh, that was sudden. So here I am at my conclusion slide. What have we learned? The thing I want to emphasize, I think, is that this is or at least I believe this to be a conservative exercise in the sense that the distributions I've chosen for plausible true battle deaths um, are sort of more conservative than the distributions that we see when we look at actually rigorously measured multipliers out in the real world. The problem with that, of course, is that those rigorously measured multipliers are largely coming to us from subnational cases. We don't have too many cases where we can make a country year estimate, although we can talk about that for El Salvador. It's weird. Um, yeah, so nevertheless, we do see some significance changes relative to what we've been assuming is perfect battle death measurement. There are a few differences between thresholds, right? If we think about 500 versus 1,000, notably, and I'm unclear about the exact provenance of this change, some of our usual suspect variables seem sensitive to battle death measurement. And that, for example, lag of the GDP per capita, or rather lag of the log of GDP per capita. Um, there's one good piece of news, which is that the sort of sensitivity of these analyses to measurement, unlike the sensitivity of the subnational results I briefly showed you earlier, almost never extends to a change in sign. So we typically see we see things getting more or less significant, and on occasion crossing a significance line or showing us that our initial baseline estimates sort of unnecessarily discarded some explanation. But we seldom see the thing that we saw in the Colombian case where uh, we actually get an opposite result. So that's nice. My initial rule of thumb is roughly what you might expect, which is that things that are really significant tend to stay that way. um, Variables that seem to have marginal baseline effects. And that is, fortunately or unfortunately, many of the variables that have sort of come after what I referred to at the beginning of the talk as the boom years. Um, right, these are variables that are sort of added in to a standard model to say, hey, this thing matters. We should think about it. um, so things like youth bulge, um, things like imports and exports, etc. So these are more likely. Maybe this is obvious. This is obvious. Nevertheless, I've shown it. These are more likely to be sensitive to variation in measurement. Um, so next steps. I'm hoping soon to produce a simulation where I model mismeasurement of battle deaths sort of in a way that is related at least somewhat to key independent variables. I'd like to be building a statistical tool. Um, and I think there's sort of a continuing project of examining subnational variation and sensitivity of event count data, which, it makes perfect sense that these would be more significant than would a Civil War onset study. Finally, and this is not on my slide, I think it's really quite interesting to consider which of these variables shows variation associated with battle death measurement, or rather variation in significance associated with variation in battle death measurement. Um, Suggests to me that measurement is associated with some independent variables more than others, suggests to me that sort of mid-size armed conflicts, so ones that are kind of right at the threshold, or conflicts that have longer duration and generally lower battle deaths and consequently can shift onset years, um, may be a bit different than our sort of standard view of Civil War. Um, but I will stop there and take questions. Thanks very much.
All right. Thank you, Amelia, for that presentation. At this point, Amelia Hoover Green is available to take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window. And I'll start by asking about an article I was thinking about that seems to be possibly related to your idea. Have you read this paper? Hold on, I pulled it up and I must have closed the window. There's a paper in Political Analysis by Drew Linzer and Jeff Lewis about measured or estimated dependent variables and how the uncertainty from that can propagate through to the model using maybe like a multi-level model or some other technique. How is that related to what you're proposing, and how is it different?
Yeah, I think so. The paper is not one that I know well. The kind of So my general impression of what I take to be sort of Bayesian measurement models, right, where we kind of propose uh, yeah, I guess I will say where we propose a given distribution and then propagate the error, um, is that it's a similar procedure. And in fact, this is what I've done for this is what we've done, obviously, for the subnational variation. Um, it remains to be seen, and people can have different opinions. But it's not clear to me that that approach is sort of amenable to um, is amenable to like the kind of investigation of the sort of differing effects of different independent variables on measurement. But yeah, I think it's certainly closely related. And
I mean, I don't necessarily know the answer either,
yeah,
but I do think that um, if you had an explicit Bayesian or multi-level model, whatever, you could have essentially, I guess it's sort of a version of a two-stage model where the first stage is the estimate of the dV, and that can actually be a function of independent variables. It can also just be a random variable. In other words, it can be a function of nothing but just random
right.
with noise. And then whatever uncertainty or bias there is in the raw measurement can then filter through into the second stage of the model where you're trying to estimate, the impact of whatever mountainous terrain or something on Civil War
Yeah.
onset.
Yeah, I mean the problem that I've had in sort of previous iterations working with that approach is that um, the what the propagation of uncertainty is kind of only part of the game, I think.
Mm-hmm.
Right? Because typically those things, when, or at least when I have used that approach on the data that I work with, have produced sort of wider confidence intervals, but not much in the way of sort of conclusions about particular coefficient estimates. But that is certainly something to move towards.
Yeah, I think what you'd have to do is you'd basically be relying on the validity of the first stage of the model, because you'd basically be arguing that I know the sources of bias and then I can correct that with a model. That actually leads to another question I had, which is I think because of this earlier paper and just sort of general statistical knowledge, I think most people can pretty quickly understand that more noise in the collection of a dependent variable is going to result in usually attenuation bias and more uncertainty in your conclusions. The effect of bias in the measurement is kind of unclear, because in a continuous context, if all the observations are just shifted down or up, it doesn't matter, right? The slope is the
Right.
same. The intercept's different, but the slope is the same. Um, of course, if the bias is selective, then it's going to make a big difference.
Right. And this is the key argument, right? Is that it's not randomly distributed.
Right.
And so, in one sense, that means, that the kind of thumb suck of just using the log normal distribution as the sort of prior doesn't get us all the way there. In another, it's sort of like, okay, well, even allowing for some sort of like lack of symmetry could help. Sorry, you were
Well,
you were
actually, what
still
what I was
asking.
thinking was
Yeah.
because that what I just said would be true in the case of a continuous DV,
Mm-hmm.
but onset is a binary DV. And as I
Right.
was sort of thinking about it, I'm not sure you could make the same argument, because I think if, for example, if there's a systematic underdetection, that's going to make all the that won't just shift the intercept down the way it would in a
Right.
continuous model. It would actually make all the slopes smaller, like another form of attenuation bias.
Hmm.
So I'm wondering if basically the question that comes out of this rambling is the binary nature of the DV something that activates special qualities for measurement error that are then especially significant for this particular application of Civil War onset?
Yeah, I think when I think about that, I think about the sort of quasi-experimental thing that's happening here, wherein we sort of some cases are safe, like there is never going to be a measured civil war in the United States during this period. There's always going to be
You think?
a, I mean, you know, I think. think. But it's a but it matters, right?
Right.
Because the U.S. is an obvious zero.
God, I hope you're right.
Afghanistan, what?
I said,
Yeah,
I hope
well,
you're right.
let's not try. Let's not go there. No, but I think the Afghanistan, right?
Right.
Always going to be a one. There's, a million deaths or something in this period. And the cases that are close to that boundary, I think, uh, are different, right? And so I'm not sure that what I obviously like, right, mismeasurement of an independent variable produces attenuation bias. Yes, that's the thing. But what I see here, and what I've seen sort of looking qualitatively through everybody's Civil War lists, is that I think there's some reasons to think that in terms of context, tactics, etc., wars that happen but don't get big, um, wars that almost happen but don't, at least according to, say, a Fearon and Leighton or a Nix Ambanis, um, conflicts that happen in UCDP but don't rise to their level of civil war, um, may have some different causal dynamics going on, or at least may have some, may be interestingly different in some way.
To what extent do you think the bias, or not bias, but errors in measurement of battle deaths are just asymmetric, meaning you're more likely to underreport than overreport, versus systematic, meaning some cases are likely to underreport relative to others?
Yeah, I mean, this is something I've thought about a lot and actually studied some. The problem for me is that it varies a lot across cases. There's always going to be some, the asymmetry thing is always true. And that's kind of what I'm targeting in this simulation exercise. The systematicity, let's say, of any given undercount, is unfortunately, like, not always, things don't always move in the same direction. So there are cases in which high and increasing violence leads to increased reporting as news media sources kind of flock to the area. There are also cases in which high and increasing violence causes a media blackout. Um, Similarly with, it's very difficult to tell whether bad weather is causing sort of diminution in actual fighting or just a diminution in the Land Rover's ability to get to the village. And on and on and on like that. So one of the problems, I think, that is just sort of stops me in my tracks sometimes, right, is the inability to, or I guess maybe I should just call it a refusal, since I'm speaking for myself, to kind of model this in a yes, we can talk about where bias comes from way.
Well, we don't have access to the true value, right? So in some sense, you'd have to have some other source of data. You'd have to have some way of actually trying to get at.
Right. And that is, I think, again, that's where multiple systems estimation is handy. So we do have some rigorous estimates. We also have survey-based estimates for a few conflicts. And, interestingly, my impression is that there has been some kind of kerfuffle, or not kerfuffle, but some thinking about how to incorporate those usually much higher death estimates into a cross-national country year data set. So what was the death toll in Guatemala? For a long time, it was, in the sub 50,000 range. And then we found out, oh, wait, there was a genocide that everybody missed.
Mm-hmm.
How do those numbers get incorporated into UCDP in a way that doesn't, mess everything up, is a problem that is way above my pay grade, but it's really interesting.
So the last question I have is, it's sort of a more conceptual question, because the premise of this project is that we're measuring. We should measure civil wars outbreaks by the number of battle deaths, and our estimate of battle deaths might be wrong. That leads me to wonder, what is a civil war? Because if I can say that 999 deaths is not a civil war, but 1,001 deaths is a civil war. Now, I'm a methodologist. I understand you got to draw lines, and the close cases are always kind of weird. But it doesn't. I guess I just don't understand why it is that a threshold for battle deaths turns something into a civil war or not. It seems like a civil war. As speaking as somebody who just sort of has read the literature a little bit and is not an expert, seems to have more going on than just people dropping dead or being killed.
Yeah.
To what is there any way that we can leverage those additional characteristics of civil war to improve the measurement?
So I am sort of all of the data that I'm using or that I'm relying on, and all of the kind of voluminous literature on Civil War that I think about all the time, um, tends to agree that one of the parties is at state, that the other party is relatively well organized, that it has a political platform, that the violence is not one-sided, all of these things. And so it seems to me that, there seems to be an assertion or a sort of we seem to have agreed, bracketing for a moment, the sort of UCDP armed conflict approach. We seem to have agreed that civil wars are big. And they are different from other forms of political violence that are small. And, at that point, it just becomes an exercise in sort of figuring out what's in and what's out according to whatever ad hoc threshold we decide. And certainly when I have done these simulations with, once I ran it with 100, 400, and 700 as the thresholds, and yes, we get relatively different results. Um, I'm not sure I have more to say than just, unfortunately, this seems to be how people are doing it. However, one thing that I found really notable as I sort of dug into the existing data on Civil War onset is I thought hard. I was like, okay, so we didn't, Fearon and Leighton, for example, just as an example, since they're famous, um, have a really clear numerical operationalization. They also have a list of civil wars from 1946 to 1999. How did they get that list of civil wars? It almost certainly was not battle deaths. Right? They were probably, or their research assistants, their enormous team, were not focused on the kind of battle death threshold. But that makes me wonder if one of the reasons that my results don't quite replicate some of the earlier results is that basically we were just missing mid-sized civil, sort of small to medium civil wars in the 50s and 60s. I don't know. Certainly that is the result that there's been a couple of research notes out of UCDP about unclear cases that seem to suggest battle deaths are a common cause of unclear cases. So, one problem is needing some sort of ad hoc line to draw. One problem is just lack of information.
Hmm.
Yeah. I had occasion to think about that quite hard when I compared sort of Fearon and Leighton to Doyle and Sambanis to various other sources, and I have no good answers.
I mean, it seems like this is a classification problem, right? And it seems like this is a classification problem where there's a multidimensional, space in which the cases lie.
Right.
And I do feel like that's something we meaning statisticians and methodologists, do know something about.
That's certainly true.
So it's a bit odd to me that, hey, if this one dimension is kind of problematic, why don't we make use of the other, 8 or 9 that we're pretty sure are out there? Like, for example, there are protests going on in Hong Kong right now, and you can imagine a case where, the PLA or whoever comes in and just massacres 1,500 protesters, but that wouldn't make it a civil war, even though
right.
There would be a lot of death.
Right.
Yeah, I don't know.
I mean, I think the problem is, right, that the people have sort of thought and thought about it and have determined that that battle death criterion or something like it is necessary because there are cases that meet all the other criteria, and we're just not sure whether there were, 250 or 1,000 battle deaths.
Right.
I think a sort of takeaway, the thing that I desperately want people to kind of realize is that in the context of political violence, the measurement really is that bad. Um, like it's so bad. The extent to which we miss and undercount things is the subject of a fair amount of kind of hand waving in articles, and sometimes that hand waving is justified, sometimes it's not. But the the reality is it's really big. It's big relative to a lot of other measurement error that we pay more attention to because we seem to have more control over it. But that is just my hobby horse.
Well, we're out of time, so I'd like to thank Amelia Hoover Green for being our presenter this week, and I want to note that her presentation will be posted to our website shortly after this broadcast if you'd like to share the presentation or watch it again later. I'd also like to invite you to join us on Friday, November 22nd, when we will host Korhan Kosak from Princeton University, giving a talk entitled, "What Do We Learn About Voter Preferences from Conjoint Experiments?" Please see our website, www.methods-colloquium.com, to get more information about this talk. Amelia, thanks for giving the talk today.
Thanks for having me.
And I hope to see everyone next week.